Hey everybody, there's your question right at the top of the screen there. Where does the line y equals 3x minus 5 intersect the circle x squared plus y squared equals 25? Okay, we could tackle this in two different ways. You could think about it graphically, which would absolutely help, or you could just play through it completely algebraically. So if I was to tackle an algebraic solution, then the first thing I might do is say, well, that line is my equation 1. My circle is equation 2. And so for me to solve that and find where do I intersect, that means I need to solve the system. So because those are different degrees, I'm going to sub equation 1 into equation 2. That means within equation 2, I can replace my y with what it's equal to, my 3x minus 5. And that then creates an equation with just x's. Now I can go ahead and I can solve that. So I'm going to go ahead and I'm going to expand my brackets, square the first, multiply those together and double it, square the last. And then I'm going to simplify and collect everything. I notice I can put together my x squared terms. I cannot collect it with my single x's, and my constants are going to cancel out, so I get that equal to 0. Okay, I cannot put my x's together into one term, so I'm going to look to factor. And so I can common factor out a 10x from both of those terms, and that's going to leave me with an x minus 3. And that product equals 0, so therefore 10x is going to equal 0, or my x minus 3 is going to equal 0. And that gives me some pretty quick equations to solve. There we go. X equals 0, x equals 3. Now, I'm not done the problem, though. The question does say where, and I might argue we answered the when. We answered for when the independent variable, that is x equals 0 and x equals 3, at those x values, that's where my line intersects my circle. However, I would need to take both of those x values and now sub x equals 0 back into equation 1 and sub x equals 3 back into equation 1. Now, there is something very interesting here of if we've often worked our way through solving systems and at times you've had somebody tell you, it doesn't really matter which one you sub back into. It absolutely matters. We'll show that when we deal with a geometric solution. But if I was to work my way through and I sub my x equals 0 back into my line, I'm going to get negative 5. Sub x equals 3 back in, and I'm going to get 9 minus 5. There's my 4. So I've actually answered this question. At 0, negative 5 is one point of intersection, and at 3, 4. Okay, I like that structure for a solution. I think it really helps. Okay, what I'm going to do is I'm just going to pop up a diagram of the situation so we can quickly see what we just worked through algebraically. So what you see on the screen now on the right, there is your blue equation 2, that being my circle, center 0, 0, radius 5. I then take a look, and my equation 1 is my line. So if I was to label that, there's my 1, there's my 2, fully labeled. What we just found out was we had a point of intersection at my green 0, negative 5, which I'm going to argue to you should make sense. If my circle has a center 0, 0 and radius 5, then if I go straight down from my center, I have to have a point on that circle at 0, negative 5. But also you take a look back up in equation 1, that is a line with a slope of 3 and a y-intercept of negative 5. So my line also has to pass through there. That could have been something that I came to graphically pretty easily. However, that other point would have been difficult to come by. We've now gone through and we figured out that the location of that was at 3, 4. Okay, graphically, that's what that looks like. I want to take one moment to hop back and address that whole situation of, but you can sub it back into either one. What I'm going to do is I'm going to take that x value of 0 And rather than sub it back into equation 1, I'm going to sub it into equation 2. Quite often we hear, it doesn't matter which one you sub it back into, but I hope that we're going to be able to see it will. If I replace my x with 0 in equation 2, then I get y squared equals 25. And when I now go to solve for y, I'm going to take the square root. And as soon as I take the square root, I know that I could have 2 possible answers. And so notice when you solve that, we're going to get plus or minus 5. So what I solved for with that blue was absolutely correct. Hey, look, there's my negative 5. But it also allowed this pink solution up top at 0, 5. You'll notice 0, 5 is a point on the circle. It satisfies that. But it is not on the line. So it cannot be a solution to our system. So my advice to you, every time you have to sub back in, make sure you are subbing back into a function, something that's going to pass the vertical line test. And in this case, sub it back into your most simplified one. Sub it back into your line. That way you're going to guarantee that you only get points of intersection. Okay, I'm hoping that helps you through that problem. Pure algebraic solution with a little bit of graphing afterwards. Okay, best of luck with your practice.